This conference will now be recorded.
All right, this is section 6.3, trig functions of real numbers. We were supposed to start this today and we're still a little bit behind. So I'm not going to do the whole video on this, but we will at least get us started. And let me get my pen. There we go. We want to make sure that we feel good about at least, halfway through this that we've gotten it covered. So the definition of a trigonometric function of a real number is that the value of a trigonometric function at a real number t is its value as an angle of t radians, provided that that value exists. Now, sometimes values will not exist because we're going to divide by 0, and that comes up especially with like tangent and cotangent and secant and cosecant. So that's when we could get some undefined values. So essentially what we're saying here is that, remember, any number that's a real number, we said could be a radian, because we've seen things like just theta equals 4. And we said even though there's no pi there, that's still radians, it's not degrees. So essentially what we're saying is that if you let theta equal some value t, so that we can measure it from here to here, from the starting point x-axis to our angle's destination essentially, then we should be able to figure out an ordered pair attached with that, and then find out the sine, cosines, tangents, cosecants, secants, and cotangents. Now, if we can put this on a unit circle, the nice thing is that and that's always the goal. We want it to have a radius of 1 so that this makes sense. You can scale a circle as large as you want, but we use the unit circle because it's an easy one to work with. So if you actually have a unit circle, then the cosine value is always just the x value. It's the point. Excuse me. And then the sine value is the y value. So, and then you can find tangent by doing y over x. And then, of course, all your reciprocals will follow from knowing those three. So let's look at this example right here. It says a point PXY is shown on this picture right here, corresponding to a real value of t. So this is some angle measure in radians. Find the value of the trigonometric functions at t. So essentially, we are saying this is on the unit circle, and we know that this guy right here then is going to be our cosine of t, and this one is going to be our sine of t. That's always going to work on the unit circle. It's going to be your cosine and your sine. So I'm going to go ahead and write those down. So sine of t is, that looks like it's positive, yeah, 8/17. Cosine of t is going to be negative 15/17. Tangent is found by putting the y value over the x value, sine over cosine. So that's going to be 8/17 over negative 15/17. Now, essentially what happens here is you get matching denominators, and it just ends up being the numerators. So negative 8/15. Once you have those three, remember you can just flip them to create your reciprocals. So 17/8 for cosecant. Secant is going to be negative 17/15. Be careful when you write cotangent because there is a t there. I usually put my angle part in a parentheses. You don't have to do that on the others, but I do it on my cotangent. And that one's going to be negative 15/8. So essentially, if you know the point value and you know that you're on a unit circle, you know your cosine, your sine, you can get the tangent from making that fraction over fraction, and then you have your other three. So same thing here. This is cosine, and this is sine. So when we write our list, so sine of t is 3/5, cosine of t is 4/5. That means tangent of t is going to be 3/4. It's the sine numerator over the cosine numerator. And then we would have cosecant of t is going to be 5/3. Secant of t is going to be 5/4. And cotangent of t is 4/3. So again, nothing new, just referencing this as a unit circle application now. All the other things work exactly the same. Now this is a little bit new concept. This is about a point P of, pretty much P of t. So they've already given us the point, and it is on the unit circle. It corresponds to some t value angle between 0 and 2 pi. That means it's one revolution of a circle, not more than one. And they're giving us some kind of reference values, so like t plus pi. So let's first of all draw what the picture looks like right now. So since both of these are a positive x and a y, that means they're in quad 1. So what we're looking at is this is kind of our angle here. This is the measure of t, and this is the point 4/5, 3/5. This says if you have t, find t plus pi. That means add pi to the t that we already have. When you add pi, you're adding 180. So this is t plus pi would be all of that. So that means that this just moves this triangle down to quad 3. All that does, since nothing else is changing about the triangle, it's an exact copy, is it changes what signs you have here. So this is now a -4/5 and a -3/5. So the answer to P of t plus pi is the same point we were given, but in a different quadrant. So -4/5, -3/5. Okay, let's draw another little picture for B part. Same thing. This is the same picture. I'm not going to write all the points again, but it's doing minus pi. Now, minus pi means you move in a clockwise direction, whereas adding, you move in a counterclockwise. So it means you're doing a negative to your angle. So we're still moving 180. So you're just moving it this direction. This is t minus the pi. Okay, so we're looking at, it's going to be down here and still the same triangle. It's the same point that it was before. It was just going the opposite direction now. So this would be still -4/5, -3/5. For this last one, this is changing the direction of the t. So what's happening here is that you had t, which was this, and now you're going to start at 0 and go -t. So that actually places your triangle in a reflection below itself. So it's just down here. This point has positive x's and negative y's. So that would be the point for that one. So this is just really just knowing, that adding or subtracting pi just moves you 180 degrees from your original terminal side. And if you make your t negative, you're flipping or essentially going the opposite direction from 0. You're changing the direction that you measure t in. Okay, and then we have this one right here, which says we're going to find the values of the trig functions at t. So we're going to draw a picture for each one of these. So for A, if your angle is 0, remember that means you didn't move at all. So you kind of have a flat little angle right here that didn't move off of the x-axis at all. The hard part about this is that there's no triangle here. So anytime you have this, you're on the unit circle. Remember, that's our standard. Think of this as an ordered pair. This would be 1, 0. It's an x-intercept because a unit circle would have a length of 1. That means your radius is 1. So when you go to write, and this is kind of your x and your y, when you go to write your ratios, remember what we know about them. We said if you're on the unit circle, sine is always just the y value. If you're on the unit circle, cosine is always just the x value. Tangent is y over x, so that's going to be 0 over 1, which is just 0. Anytime you do a reciprocal of 0, and actually let me change the way I'm writing this. I can't really erase it, but we know that these are all a value of 0. So instead of writing theta or t, we should actually write 0 in here. It's just very easy to write theta all the time. So cosecant of 0 is going to be the flip of this 0. Remember, this is 0 over 1. So if you flip it, it's going to be undefined. Secant of 0 is a flip of 1. 1 flipped is still 1. Cotangent of 0 is a flip of this 0. So 0 will end up on the bottom, so it's undefined. You'll notice a pattern that anytime something is 0, the other part, the reciprocal, is undefined. If something is undefined, the reciprocal is 0. Okay, so let's do B. B is pi over 4, which is a 45-degree angle, so that puts us right here. So that means we still have a radius of 1, and then the 45-degree angle, remember we had a special point for that on our unit circle. That was square root of 2 over 2 and square root of 2 over 2. So remember, this is our x, this is our y. So sine of pi over 4 is the y value, so that's going to be square root of 2 over 2. Cosine of pi over 4 is the x value, which just happens to be the same. Tangent of pi over 4 is sine over cosine, which is going to be 1, which makes sense. The tangent here is going to always be the y over the x. And then we flip these. So the only problem with flipping them is, remember, you're going to get a square root in the bottom. So if you flip this, it'd be 2 over square root of 2, and then we need to rationalize it. So when we rationalize it, I'm doing this one worked out, and then the other one works the same. This is 2 square root of 2 over square root of 4, which is 2. So notice the 2's are going to cancel. It's just going to be square root of 2. So secant of pi over 4 will also be just square root of 2. And cotangent is just flipping a 1, so it's still going to be 1. Okay, let's do the last one. C is pi over 2. So pi over 2 is straight up and down on the y-axis. So this has a radius of 1, and it has the ordered pair of, this would be 0, 1. So sine is the y value, so sine of pi over 2 is 1. Cosine of pi over 2 is the x value, which is 0. When you put 1 over 0, because remember we always put y over x for tangent, you get undefined. So now we do our flips. Cosecant of pi over 2 is still going to be 1. Secant is flipping a 0 to the bottom, so that's going to be undefined, and I don't really have a lot of room to write that, so undefined. And then the cotangent is flipping the undefined, so that's going to put a 0 back on top. So remember, the 0 and undefineds are always flips of each other from the reciprocals. Okay, just to remind you of the unit circle. Remember, we did that in class last time. This doesn't have all the degrees on here, but it has all of the radian values, and remember the ordered pairs that are kind of corresponding to that. And then up here, it reminds you that if you're on the unit circle, then cosine is always the x value of your angle, and sine of the angle is always the y value. Some people will ask me what happens if I'm not on a unit circle. Well, you put your radius of your circle in front of each of these. So if your radius of your circle is 5, it would be 5 times cosine t and 5 times sine t. So you still use these same points. You just scale it by the radius. So that's an interesting thing and why we teach it to you as the unit circle. And then this is just reminding you how to find tangent, cotangent, secant, and cosecant, since these are specifically cosine and sine. Okay, I believe this is going to be the last one that I do, on this part, and then we'll pick up with the next slide when we get to class on Wednesday. So let P be the point on the unit circle, and it's going to be corresponding to an angle T. Find the coordinates of P, so we want to find the actual ordered pair, and the exact value of the trig functions of T whenever possible. So I have lost my ink. Hang on just a second. Let's see. My mouse is not working.
This conference will now be recorded.
Sorry, I had to reset the recording because my mouse was malfunctioning. So we're looking at this first one as negative pi. Okay, so let's draw a picture. Pictures are always helpful. Negative pi means you go this direction 180 degrees. So this is negative pi. That is going to be the ordered pair if we're on the unit circle. This would be negative 1, 0. So when we go to write our information, we need to know that sine of negative, so that was my coordinate. So P is negative 1, 0. That's the point. That was one thing they asked for. Sine of negative pi is the y value there, so that's 0. Cosine of negative pi is the x value, so that's negative 1. Tangent of negative pi is y over x, so 0 over negative 1 is 0. Cosecant would be the flip, so that's going to make that undefined. Secant is the flip of negative 1, which would still be negative 1. And then tangent, or excuse me, cotangent. Cotangent of negative pi is a flipping of a 0, so that's going to make it undefined. So that is 10. So there's all my trig values, and there's the ordered pair that went with that on the unit circle. Okay, so let's do 6 pi. 6 pi means we go around the circle multiple times. So remember, this is 2 pi. If we go around again, that's 4 pi. If we go around again, that's 6 pi. So 6 pi actually is just 3 rotations around the circle. So that's the ordered pair 1, 0. It's an x-intercept. So sine of 6 pi is the y value, so that's 0. Cosine of 6 pi is the x value, which is 1. Tangent of 6 pi is y over x, so that's going to be 0. And then remember, we do all of our reciprocals. So cosecant would become undefined. Secant would still be a 1. And cotangent of 6 pi would be undefined. So those are not as interesting because this is on kind of the quadrant angles. Those are the ones that are on the x or y axis. Essentially, you get lots of 1s, 0s, and undefined. So let's do some that are actually kind of out in space a little bit. So 9 pi over 4. If you're not sure where that is, imagine subtracting 2 pi from it to see if it's actually more than one rotation around the circle. 2 pi would be 8 pi over 4, because remember, we have to convert it to same denominator. So if you do that, you notice that this is just pi over 4. So 9 pi over 4 falls in the exact same location as pi over 4. It's just an extra rotation around the circle. So that means that that's the ordered pair, square root of 2 over 2, square root of 2 over 2. So that tells us our sine and cosine right away. So sine is the y value there. So sine of 9 pi over 4 is square root of 2 over 2. Cosine of 9 pi over 4 is the x value. So that's also square root of 2 over 2. Tangent, oops, I'm a little too low on that thing. So tangent of 9 pi over 4 is putting those as y, pretty much sine over cosine. So that's just going to be 1. Our reciprocals are going to be, anytime you flip square root of 2 over 2, it ends up just being a square root of 2. You get that from rationalizing. We did that in one of the last videos. 9 pi over 4 secant is just going to be square root of 2 if you rationalize. And then cotangent would still be 1. Now, if you need to show the rationalizing steps, that's fine. It would be 2 over square root of 2, and then you rationalize, but it reduces down to just square root of 2. So there's my point, and there's my 6 trig values. Okay, last one, negative 5 pi over 4. So that means we're going this direction. So negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4 is negative pi, negative 5 pi over 4. So it's going to end up in quad 2. So this is negative 5 pi over 4. That is still a 45-degree angle here, so that's going to be square root of 2 over 2 on both points. But because we're in quad 2, that means the x one is negative and the y one is positive. So when we go to do cosine and sine, we'll have to take that into effect. So sine of negative 5 pi over 4 is the y value, so that's square root of 2 over 2. Cosine of negative 5 pi over 4 is the x value, so that's going to be a negative 1. Tangent is sine over cosine, which that's a positive over a negative, and they're the same, so that's going to be negative 1. Then we flip them, so this would be cosecant of negative 5 pi over 4 is going to be just square root of 2. Secant of negative 5 pi over 4 after rationalizing will be negative square root of 2. And cotangent of negative 5 pi over 4 is going to be negative 1 still, which that didn't show up very good, but it's negative 1. So there are my 6 trig values again, and my point is right here. So essentially, I mean, what you notice is that we're doing the same kind of thing over and over again by finding these 6 trig values. We're just relating it to how did they present the information. So when we get together on Wednesday, the first thing we're going to talk about is what are the general shapes of the trig graphs. And then we're going to show you how to use those pictures to answer a few questions. And then that leads us into section 6.4, which is actually only 8 slides. So it's a shorter section. So if not completely caught up by Wednesday, we will definitely be caught up and back on track by Monday of next week. Hopefully you found these videos helpful, and I will see you guys on class on Wednesday. So have a good day.